Alrighty, so today we're going to be having a look at the derivative of tan of x. Now, we could look at a more official proof. I'm going to be proving it using the quotient rule. Why can I prove tan of x's derivative using the quotient rule? Well, it comes down to the definition of tan of x. So if I think about a function, y is equal to tan of x, well, I could instead think of it as sine of x over cosine of x. Now, I know how to derive this. It's a bit of a pain, but I can do it. How? Using the quotient rule. Now, just as a reminder, quotient rule says if you've got a function u over v and we're trying to derive it, well, it's the derivative of the top times bottom minus the derivative of the bottom times top all over the bottom squared. Okay? So we've got that exact situation here. The top is sine of x, the bottom is cosine of x, so we get u is equal to sine of x, v is equal to cos of x, u dash, well, derivative of sine is cos of x, and the derivative of cos is negative sine of x. Now, if you weren't sure of that for some reason, which is perfectly reasonable, just as a reminder, sine goes to cos goes to negative sine, and sine goes to negative cos, and we get our loop of derivatives set out. Obviously, it's on the formula sheet as well, but I always like to have it there just as a bit of help. So, now we can just go through and do quotient rule. So dy dx is going to be u dash v minus v dash u all over v squared. Or, better written, cos of x times sine of x. No, sorry, cos of x times cos of x minus, and then we're going to get sine of, negative sine of x cos of x. Sine of x. Sorry, just had a bit of fun. Remembering, you're always going to be looking at these two together and these two together when using the quotient rule. Now, on the bottom, we're going to get something quite nice because it's just going to be sine squared. Cool. Alrighty, all over cos of x squared. Now, a few videos ago, or last video, we were looking at something that looks like this. And remember, we learnt that it's better to write that as cos 2 of x, right? It means cos x squared, but we write it as cos 2 of x, just notation. But we can also use that on the top. Why? Because this is cos x times cos x. Cos x times cos x is just cos 2 of x. And we've got minus minus over here, right? So those are going to become plus. And then it's sine x times sine x, so it's sine squared of x. Now, you might not remember this, but it's a true fact. If you add cos squared x plus sine squared of x, that's equal to 1. This is actually what's called the Pythagorean identity. So the whole top just becomes 1. And we're done. So what we get is that the derivative of tan is equal to 1 over cos squared x. So d dx of tan of x is just 1 over cos squared of x. And that is how we derive tan. Let's do a couple. Alrighty, so we've got y is equal to tan of x. Alrighty, I just said what the rule was, but derivative of tan of x is equal to 1 on cos squared x. B, the derivative of 3 tan x is going to be 3 times 1 over the cos squared of x. Where does the 3 go? The 3 goes on the top. because remember, constants do not get derived, they just kind of hang out at the front. Alrighty, and for c, well, we're going to get a very similar story from the previous one, so the negative 3 can just hang out the front. The derivative of tan of x is 1 over 1 on cos x. Oh, okay, but it was tan of 2x, so now it's going to be 1 cos squared of 2x. But chain rule says multiply by the derivative of what was in the brackets, which is 2. And we just need to do a bit of simplifying. Negative 3 times 1 times 2 is negative 6. And the denominator is just going to be cos squared of 2x. And that is how you derive tan of x. See you in the next one. Goodbye.